Welcome back to our channel. Have you ever wondered what it would take to send a message from Earth to Mars? You might be used to sending a text or email and receiving a reply within seconds. But when it comes to communicating with a planet millions of kilometers away, it's a whole different story. In today's video, we're going to dive into the cosmic challenges of space communication, exploring how long it takes for a message to travel to Mars, and why the journey of that message is more fascinating than you might think. So, buckle up and get ready to journey through space as we uncover the mysteries of interplanetary communication. To understand how long it takes for a message to reach Mars, we first need to talk about the speed of light. Light travels at an incredible speed of about 299,792 kilometers per second, or around 186,282 miles per second. In simpler terms, if you could travel at the speed of light, you could circle the Earth about 7.5 times in just 1 second. When we send messages to space, these messages travel in the form of radio waves, which move at the speed of light. But here's the catch. Even at that incredible speed, space is unimaginably vast, and distances between planets like Earth and Mars are so huge that it still takes a significant amount of time for those messages to travel. One important factor to consider is that the distance between Earth and Mars is not constant. Both planets are in orbit around the Sun, and as they move, the distance between them changes significantly. When Earth and Mars are at their closest point, known as opposition, they can be about 54.6 million kilometers, around 33.9 million miles apart. But when they're at their farthest distance, called conjunction, they can be as far as 401 million kilometers, around 249 million miles apart. This means the time it takes for a message to travel between Earth and Mars can vary widely. At its shortest, it might take as little as 3 minutes, but at its longest, it could take up to 22 minutes. So every time we send a command to a rover on Mars, we have to wait several minutes or even longer to know if the message was received. Let's take a real-world example to make this clearer. Imagine you're a NASA engineer sending a command to the Perseverance rover on Mars to move its robotic arm or take a picture. At the current average distance, which is about 225 million kilometers, it would take approximately 12.5 minutes for your command to reach the rover. But here's the thing. You won't get an immediate response. Once the rover receives the command and completes the action, it sends data back to Earth, which takes another 12.5 minutes. That means there's a round-trip delay of about 25 minutes. This delay is one of the biggest challenges faced by scientists and engineers when controlling robots on other planets. Distance isn't the only factor that affects how long it takes for a message to reach Mars. There are other cosmic obstacles too. For instance, solar storms can interfere with radio waves, disrupting communication and delaying the time it takes for signals to reach their destination. Additionally, the positions of Earth and Mars relative to the Sun play a role. If the Sun is positioned directly between Earth and Mars, its powerful radiation can block or distort the signal entirely. This phenomenon is known as a solar conjunction, and during these periods, communication with Mars can be nearly impossible for a few days. So, how do we actually send these messages across millions of kilometers? This is where the Deep Space Network, DSN, comes in. A global system of giant radio antennas managed by NASA. The DSN has 3 main facilities located around the world, one in California, one in Spain, and one in Australia. These massive antennas are responsible for sending commands to spacecraft and receiving data from missions in deep space. The DSN works by transmitting radio waves at high frequencies, which travel through space at the speed of light. Even though these signals are incredibly fast, the vast distance between planets means we need to be very precise and patient when sending and receiving data. Without the DSN, our communication with distant planets and spacecraft would be impossible. Understanding how long it takes for a message to reach Mars is more than just a fun fact. It's a critical part of planning future space missions. As humanity prepares to send astronauts to Mars, communication delays will play a major role in how we design our missions. Imagine being an astronaut on Mars, needing help with a technical issue, and knowing that your question won't be answered for at least 20 minutes. Scientists are already exploring new technologies to speed up communication, like laser-based systems that could potentially transmit data faster than radio waves. And who knows, in the distant future, we might even develop methods of instant communication using quantum entanglement, an area that's still largely theoretical but incredibly exciting. So, the next time you send a text message and get frustrated waiting for a reply, just remember, communicating with Mars is a whole different ballgame. A simple message traveling at the speed of light can still take minutes, or even tens of minutes, to reach its destination. But every second of that wait brings us closer to understanding the universe and possibly expanding our presence in it. The challenges of space communication are just another reminder of how vast and incredible our cosmos truly is. If you enjoyed exploring the wonders of interplanetary communication with us today, don't forget to hit the like button, subscribe to our channel, and click the bell icon to stay updated on all things space. Let us know in the comments if you think we'll ever be able to achieve instant communication across the cosmos. Thanks for watching, and keep looking up. The universe is full of mysteries waiting to be uncovered.